Chess is a game of strategy where two players face each other to find who's the best at executing plans with an army of pieces. This game is famous for its complexity. Each piece moves differently, and you need to be aware of how to use their movement in sync to complete an attack to the enemy king. Imagine coming up with code that follows the rules and logic of this game. This is my journey at programming a functional chess application. I made this project with the C++ programming language. I began this project using the console to output the game. The first step was to build the board, which I may use in a two-dimensional array, where each element was a chess piece object. A chess piece object contained the color, a character specifying the piece, and its position on the board. I named this array chessboard and initialized it with only empty spaces. I also made two extra arrays, one for the white pieces and the other for the black pieces. In the arrays, each piece was represented by a letter, and a star event was an empty space. Also, the color was identified by a number: 0 for white, 1 for black, and 2 for empty. So far, my board looked like this, just a bunch of stars. So I added the pieces to the corresponding positions. It was time to make the game logic. For this, I made two functions, one called move pieces and the other one called valid move. The first one would just perform the move, updating the board. The second one is the most interesting one, and the one I will talk the most since it holds all the logic of chess, verifying if the potential move follows the rules of chess. I decided to begin to code the movement of the knight, since this piece has a peculiar ability. It can jump over other pieces, which made the coding just look at the square where it was going to land and making sure that there was not a piece of the same color on it. Now, the knight never stays on the same column or row when it moves. Also, the total of the distance is always 3. That's how I implemented the code for the horse, making an if-else if statement verifying those two conditions. With that, I was over with the knight. The movement of the rook is simple. He only moves on the current row or current column. The only difficulty here was to verify that there wasn't any piece on the path it was going to traverse. I solved this with a loop, verifying each square on the pad. The bishop was also easy to code, since I only had to make sure to check if the row and column changed by the same value. I used a similar loop to verify that the pad was empty, just like the rook. Now, for the queen, it requires the most effort in the history of programming. Yeah, it was that easy. The pawn was one of the hardest pieces to code, because they have plenty of special moves. They have the regular move, which is just moving forward one step at a time. For white, it's moving forward this direction, and for black, it's on this direction. So I already had to write specific cases depending on their color. If a pawn hasn't moved at all, it can make a double step, which is moving 2 squares forward in one turn. They can only do this if they are on their original row, which is how I coded this move. Pawns also capture differently from how they move. They can only capture a piece if it is on one of the diagonals just in front of them. They can also do a move called en passant. This move requires the previous move to be a double step by a pawn of the other color, and also that this pawn is on a column next to the pawn that wants to make the move. This is a special case of the capturing move. It has to be done in that moment. This move will capture the other pawn as it was on a diagonal in front. To code this, I had to make sure that the pawn wanted to do a capturing move to a square that was empty, and that the previous move was made by the pawn on the column it wanted to move, and then on the same row as the column pawn. For this to work, I augmented my movement functions with a parameter that stored the previous move. The last trick of the pawn is that it gets upgraded to any other piece, except to a king, once it reaches the furthest row from where it started. I coded this along the Win32 features. With the pawn out of the way, the only piece left to code is the king. The moves of the king are simple. It can only move one square to any direction. It can also do this castle thing with the rook if neither of them have moved. This I solved with a bunch of flags. The only real restriction is that it cannot move to a square when he will get captured in the next turn. This is called check, and this concept was the hardest thing to program. And this is because the check concept extends to moving other pieces. You can move a piece if this will leave the king on a check, and if the king is on check, you have to make sure a move that will eliminate this threat by moving the king, blocking with another piece, or capturing the piece that is checking. If no such move is possible, it's the game over. As you see, there are many exceptions in normal movement, so I made a whole new function called isOnCheck to work that logic. This function will be called by the valid function with a specific color, and it will look through all pieces of the opposite color and verify if one of those pieces can capture the king in the future state of the board. If at least one can, it will return true and make the test move not valid. This function and the valid move have a mutual recursion. Valid will call the check function, and the check will call the valid function. So I added a flag to the valid function so that it will not call the check function if it was called by it. This function showed me a bunch of bugs in my code. All these bugs were easy to discover when I moved from just the console output to Win32. It took me some videos to understand enough of Win32 to do this application. I watched the Pentamolist Project video series to understand how to build a window with buttons that could change its image when pressed. Once I had the buttons with identification, I created a function mapping the buttons with a specific element in the chessboard array. I also made a stack that would store the ID of the buttons that got pressed. Once the stack had two elements, a code block would run, popping the two elements of the stack, translating them to array elements, and calling the move function to update the board if the move was valid. For the pawn upgrade, a child window will pop up with buttons that let you choose the upgrade you want to apply to the pawn. Last thing I added was the option to create a new game, which resets the board. There are other features that can be added, like flipping the board for black, and an undo button to go back in turns, a text box outputting the moves, and making the board look like an actual chessboard. I could keep going, but I feel this works with what it has. This was my journey building a chess application.